This video is presented to you by www.testprepadda.com. Dear students, in this video lecture, I will start the discussion of laws of chemical combinations. Dear students, on the basis of quantitative studies of different reactions, it is observed that whenever substances react, they do so according to certain laws. These laws are called laws of chemical combinations. The first law is law of conservation of mass. The second law is law of definite proportions, which is also known as law of constant composition. Third is law of multiple proportions. Fourth is law of reciprocal proportions. Fifth is Gay-Lussac's law of combining volumes. In this video session, I will talk about two laws, law of conservation of mass and law of constant composition. While in the next video lecture, I will talk about law of multiple proportions, law of reciprocal proportions, and Gay-Lussac's law of combining volumes. So now the first law, that is law of conservation of mass. This law was given in 1774 by a French chemist Antoine Laurent Lavoisier. According to the law, during any physical or chemical change, the total mass of products equal to the total mass of the reactants. For example, if I write the dissociation of calcium carbonate CaCO3, when this CaCO3 is heated, we get CaO plus CO2. Now, if I write the molar mass of calcium carbonate, it is 40 plus 12 plus 16 into 3, that is 48, and this comes 100 gram. Calcium oxide, if I write the molar mass, it will be 40 plus 16 means 56. If I write the molar mass of CO2, it will be 12 plus 32, 16 into 2, 32, and that is 44. Now, as per the mole concept, we say one calcium carbonate gives one calcium oxide and one CO2. And mass wise, if I try to say that 100 gram of calcium carbonate gives 56 gram of calcium oxide and 44 grams of CO2. Now 100 gram is what? Mass of the reactant. 56 plus 44. So I will write mass of products is equal to 56 plus 44, and that comes 100 gram, while mass of the reactant is also 100 gram. So mass of the products is equal to mass of the reactant, and that is given in the law of conservation of mass. Now, to understand this law in a better manner, I will take a question here. Here the question says, if 12.6 gram of sodium bicarbonate are added to 30 gram acetic acid, the residue is found to weigh 36 grams, what is the mass of CO2 gas released in the reaction? Let me write the reaction first. Sodium bicarbonate, when reacted with acetic acid, a carboxylic acid, then we get sodium acetate plus H2O plus CO2. CO2 gas is liberated here. Okay, question says initially you have 12.6 gram of sodium bicarbonate and 30 gram of acetic acid. So the total mass I can say as 42.6 gram. Now, after the reaction, it says the residue is found to be 36 gram. Residue 36 gram. And weight of CO2 liberated we have to find. Let the weight as x gram. So, I have to write according to law of conservation of mass, 42.6 is equal to 36 plus x. This way the value of x comes as 6.6 grams. So the mass of CO2 gas released in the reaction is how much? 6.6 grams. Now dear students, please take care while using this law. Those cases where two or more reactants are involved and one reactant is limiting reagent, then law should be written in a different manner. I'll tell you how. So those cases where one component is limiting reagent and others are in excess, then we should write mass of the products formed plus mass of unreacted reactants is equal to mass of reactants given, or it is better to write in this manner: whatever mass given initially, initial total mass is equal to final total mass. This is the best way to express law of conservation of mass. Initial total mass is equal to final total mass. My point is clear. For example, if I take HCl reaction with NaOH, we get NaCl and H2O. Now if I say initially we have mixed 73 gram of HCl with 40 gram of NaOH. So what will you write? Initial mass, below HCl you'll write 73 gram, below NaOH you'll write 40 gram. Initially we do not have NaCl, 0, we do not have H2O, 0. Now final mass means after reaction. So we have to use mass concept here, do the groundwork we discussed in limiting reagent session. 1 into molar mass of HCl is 1 plus 35.5, that is 36.5. So here I'll write 36.5 gram. Here the NaOH 23 plus 16 plus 1 means 40 gram. Here 23 plus 35.5, that is 58.5 gram. Here 2 plus 16, 18 grams. So what will you say? That 36.5 gram HCl on reaction with 40 grams of NaOH gave 58.5 gram of NaCl and 18 gram of H2O. Now look at the given masses. If you look at the given masses and compare these two, you will say 40 requires 36.5. 40 requires 36.5, but given HCl is 73 grams. That is why we say this is given in excess. So NaOH is the limiting, and we had discussed in that session that the final amount of limiting reagent is always 0, and the limiting reagent decides the amounts of all other components. So we will compare NaOH with others. 40 gram gives 58.5 and given also 40 gram. So here you will get 58.5 gram of NaCl. 40 gives 18. 40 will give 18. So here H2O 18. Now 40 requires 36.5. Since 36.5 will be consumed HCl, the remaining will be 73 minus 36.5, and this value is 36.5 gram. My point is clear. Now what is the total initial mass? Initial total mass is 73 plus 40, and that is 113 gram. 113 gram. Now finally look at the products. Products 58.5 plus 18, and this value is 76.5. If you do not add the unreacted reactant, your mass of the product will not be equal to mass of the reactants. So if I use this one, initial total mass, you can see 113 gram, and final total mass, look at this part, final total mass 36.5 plus 58.5 plus 18, this is also 113 gram. So initial total mass is equal to final total mass. That is the law of conservation of mass. My point is clear. Now I will take the another law here. Law of definite proportions, also known as law of constant composition. This law was given in 1799 by a French chemist, Joseph Proust. According to the law, a chemical compound contains same elements combined together in same proportions by mass. For example, if I take H2O, for example, if I take CO2, for example, if I take NH3, when I say H2O, you use any method of preparation. You prepare this H2O or water in any part of the world. You prepare this water in India, China, England, anywhere. The water will always be prepared with the help of H and O. Or better I say, this water will always contain H and O only. And the mass ratio will always be 2 is to 16, means 1 is to 8. So once H2O or water is formed, the hydrogen oxygen will combine in 1:8 by mass. My point is clear. Similarly, carbon dioxide will only contain carbon and oxygen, and the mass ratio will always be 12 is to 32, means 3 is to 8 by mass. Similarly, NH3, that is ammonia. Whenever ammonia is formed, ammonia will always contain nitrogen and hydrogen. And in what mass ratio? 14 is to 3. 14 is to 3 by mass. My point is clear that a compound will always contain the same elements and the mass ratio is definite, constant. Okay. Now, to understand this law in a better manner, I will take a question here. Here the question says, weight of copper oxide obtained by treating 1.08 gram of metallic copper with HNO3 and subsequent ignition was 1.35 gram. In another experiment, 2.3 gram of same copper oxide on reduction gives 1.84 gram of copper. Show that these results illustrate the law of definite proportion. So there are two experiments here. Experiment 1, experiment 2. In first experiment, copper is reacted with HNO3, then further it is heated, and this way we get copper oxide. Copper oxide. Now in another experiment, copper oxide gives copper. In the first case, copper used is 1.08 gram and the copper oxide obtained is 1.35 gram. So whatever copper used is actually converted into copper oxide. So in this copper oxide, if you write mass of copper, it will be 1.08. And what will be mass of oxygen? Copper oxide means copper and oxygen. So mass of oxygen will be 1.35 minus 1.08. So if I try to find percentage of copper in this copper oxide, I will write 1.08 upon 1.35 into 100. If you solve, this comes 80%. Now, percentage of oxygen will be 1.35 minus 1.08 upon 1.35 into 100. This comes 20%. So, in copper oxide, we are getting 80% copper and 20% oxygen with the help of experiment 1. In the experiment 2, copper oxide given is 2.3 gram and copper is given as 1.84 gram. So whatever copper present in copper oxide is converted into copper metal. So I can say mass of copper in this 1.84 gram and mass of oxygen is equal to 2.3 minus 1.84, which I can write as 0.46 gram. So if I try to find percentage of copper in the copper oxide with the help of experiment 2, I can write this as 1.84 upon 2.3 into 100. The value comes as 80. and percentage of oxygen comes as 0.46 upon 2.3 into 100. The value comes as 20. So the percentage of copper and oxygen are same in both the cases, in both the experiments. So the law of constant composition is illustrated here. My point is clear? Now, in the next video lecture, we will talk about law of multiple proportions, law of reciprocal proportions, and Gay-Lussac's law of combining volumes. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.